Hi guys, this is Mr. Yambao. Since I am not there, I'm going to continue with the forces unit today for you guys. See, look, I'm drawing it for you. Awesome. So today, my plan was to talk about what do you call it? Friction, right? We're gonna start with friction. We're gonna go over other things later. So my plan is to do some problems, but I want to start with friction today. So what is friction? Friction is one of our forces, right? It is a resisted force, and it can be used, it can either be used in a good way or a bad way, right? Like we use friction when we do like a car, right? Car, we use friction to stop it. It has brakes right there. So in a car, like when you press the brake, it converts mechanical energy to pretty much like heat, right? Like heat is pretty much friction itself. Like yeah. So here, let's start with something simple. Like doing breaks, that's not that easy to do. So I'm gonna start with something like what we always do. I'm gonna start with our box here. Right? So if you have a box, it's on the ground and it's just standing still, like I was saying to you guys, the free body for this FBB is this. I have two forces, right? I have my force of gravity, force of normal, which is my reaction force. So when I start moving that box, let's say I have with force F, whatever, um, I'm gonna start like pulling it, right? Whatever. But then instead of being, so this one's easy to do, right? Sum of forces equals to in the x direction, make sure you make it positive. So the only thing in the x direction is F is equals to an A in the x direction. So if I know the mass of this thing, whatever it is, my acceleration is just the ratio of my force over the mass, right? So obviously, the heavier the mass, the less acceleration I have. Or the other way, if F is bigger, this one gets bigger. If this is bigger, this would go smaller, right? The inverse relationship. So the only difference is when this is without friction, right? Without friction. And that's what we've been doing in the past few weeks. We have no friction. You know what? Let me go back. What happens with friction? So I want y'all to imagine, right? If I zoom in like here, somewhere, I'm gonna try to draw it. So friction is caused by little imperfections in my material, right? Let me see. Let's say I zoomed in to that thing. Okay, I'm using my engineering skills for you. Zoom in. Imagine you're zoomed in using a microscope. Um, those little ridges are resisting motion, right? Like each one of those is like not fully smooth. Nothing in this world is like fully smooth. Like there's always going to be ridges on it. So what happens is I create like friction there, right, between the two surfaces, and then depending on the surface, obviously, well, not obviously, but depending on the surface, I can have more friction. So the way we do that is called something called mu. So Greek letter mu, right? I think that's how you spell it. I'll have to look it up later. So mu is my coefficient of friction. So if I have a coefficient, like you guys have learned, it's gonna be from 0 to 1, right? So the bigger the number, the bigger the coefficient. So like an example, like compared like mm, since we were talking about cars, right? Um, you have a wheel and it's on concrete and rubber, right? I actually don't know what the coefficient is, but I'm pretty sure it's close to 1. Like it's like close-ish to 1. Probably like 0.90, I'm assuming. I'll have to look it up. Between rubber and concrete, like that's pretty high friction in my opinion. Um, but like let's say ice, like we have ice surface, right? And the wheel, that's why like it's gonna be relatively low, right? It's gonna be closer to like I don't know, 0.1 or something. I'll have to look it up again, you guys. I'm sorry. So that coefficient matters, right? Okay. Let's see, where was I? Okay. So the force of friction, I don't know if you guys have learned it in class, but I'm gonna teach you anyways. It's gonna be mu Fn. Fn is for the normal force, right? Um, so depending on how much my Fn is, so let's say let me draw my box again. So depending on how, I'm just gonna draw the free body on the item itself. Depending how Fn is, right? Friction will be the other way, right? It resist motion, the F small f. You know what? I'm gonna spell it. No, never mind. Whatever way my acceleration is, let's say A is going this way, right? To the right, the blue. Well, friction will be the other way. It's gonna resist that motion. Okay. So we'll do an example. So like this one for this problem, I'm gonna set that as my positive. So the sum of the forces in the x, right, is positive is just force, this one, minus that force of friction equals 2. But now I have an acceleration, right? As well. So the way I do these problems is I convert this to this. Right? It's just gonna be force minus mu Fm. And and then depending on my problem, so that's gonna be the next topic, just changes. So let's kind of go over that. So mu is friction, right? And it has two types. I have something called static. So the way they do that is they just call it mu s for static and kinetic, or some people, fancy people call it dynamic, whatever they want to call it. Uh, mu k for kinetic, right? So mu s, the static friction, will always be bigger than my kinetic. So what does that mean? So that means it is harder to start some. It's harder for something to start moving, right? So like, let's say I have a dude here trying to push this, trying to push, right, with a force. It's harder for you to start moving it than to than it's or than if it's already moving, right? Like you can kind of see this, like when you're pushing the car, right, or something. I'd push the car. Like my sister ran out of gas, so one day I had to like push it up the hill. Not fun, but anyway, anyway. Um, I was pushing the car, and it's harder to push it like in the beginning, right? The reason being is you guys are going to see a graph. I don't know. I know they show it on the AP test. So let me look it up real quick. I think it's called force applied versus force uh to overcome friction, to overcome. So what happens is when you get like the ratio, it's gonna look like kind of like this. This is like where my US is. This is where my mu K is. So like you have, y'all remember in like in chemistry where you have to have a what's that name? Um, you have to like overcome some kind of energy, right? Same thing for here. Um, well, you have to overcome that, and then it's easier to like this part is easier to apply that force. So here, like I said, mu S is gonna be bigger than mu. Okay. For this problem, depending if it's already moving, this is probably mu K if it's moving already. So if I want to solve for acceleration, I just have to divide by that mass again. Oh, here, sorry, I forgot. And then you have to solve for, let me move this over. You have to solve for the y as well, right? And the y is easy. And it's just up is positive, so Fm minus Fg equals to 0 because there's no acceleration in the y. So Fm, this goes equals to Fg. And then Fg is equals to mg. So Fn is mg. Be careful with this. This always changes. This is not always true, right? Like I said, depending on if there's an acceleration up here pressing down. Like if you're pressing down, Fn will increase, right? If you're like pulling up, Fn will decrease. So don't get tricked. Like they're gonna ask you this question. Fn, I'm just gonna put an asterisk, right? Don't be tricked. This one, there's no acceleration in the y, there's no movement, just staying here relatively still, right? Fn is equals to mg, but that's not always true. Okay, and then after that. So now what I can do is I can take this equation, I'm gonna plug that in, Fn. So then we'll turn by the red and the blue, so y'all don't get confused. F minus mu k mg equals to a divided by m, divided by m. So this is the reason why I tell you guys not to put numbers yet. There's a lot of stuff that's canceled out. So like this cancels that cancels that. So in the end, if I know my force, I divide it by my mass, minus mu k times g equals a. And then usually on my problems, I know all of these. So and then I can solve for stuff, right? Okay. That's usually how, it's not that bad. You just add like another force to your problem. Right? Okay. So we'll do examples in the following. You know what, you guys? I totally forgot to do some example or more some tricks to show y'all. Yeah. So an example. You're gonna get problems like this on the repeat or even in school, right? Let's say I have two weights. They're attached by a string, right? Um, I'm gonna give an example. Let's make this 1 kg and 2 kg, right? Let's say I apply a force on it. I'm gonna ask you about the tension here, and they're gonna be like, "Hey, what tension is there?" And depending on the problem, there might be more here or here, right? It's like a little train. So like, I'll show you what to do with these. Okay. So what I like to do is remember how I told you guys you can like do a system, right, or change your system. Because individually, right, you should have internal free body diagrams. Yeah, let me show you what I mean. So free body diagram for this, what's this? Eh, that way, right? If I do free body, remember for this, I have a tension going this way, it's getting pulled. So if I have a tension going that way for that one, equal and opposite for the other one, right? So the only forces on this is this one and this one, and they should be equal, right? So then my next question is, how do I do this? So what I like to show my students is what you can do, and there's another set of equations we can use. Because what you can do is you can change your system. So this whole system here, right? I can combine these two weights into one. So it can be like, hey, instead of 1 and 2 kilogram, give them just the same, right? And this. Because now what that allows me to do is to find the acceleration for the system, right? If I know the acceleration for the whole system, then I know that the individual ones should move at that same rate, right? At that same A. Um, so let's see. So like I said before, force external, meaning external force, the only thing here is this one equals to MA, right? So the only force I have is F and A for this problem, and there's 3 times A. F, sorry, so for A is just F divided by 3. So it's just a ratio of whatever uh, F is and the weight, right? Sorry, the weight, the masses. So because now what I can do is I can solve for this one right here, right? If I have the T, that's the easier one to solve. I can solve for the 1 kilogram one. T is going this way. And if I solve for same thing, the sum of masses is MA. The only force here is tension. The mass is 1 times A. And I know A. A is just force divided by 3 from this previous one, right? Plug it in. So tension is just over 3. So I can kind of generalize that, right? So what did I do? So if I um, do this problem, or I kind of just go back, this right here, this mass right here is just the mass behind the rope, right? So you can use this fact. And then A I have to solve for. And A solve for it. Right? So let's say I have a big string of masses like this. I don't know, they can be anything. 10, 20, 30, 40. If I apply a force, and I need to find the tension here, all I need to do is follow that rule is tension is mass behind rope times A, and all of these are behind the rope, right? So how many is that? 50, 60, 60. Then I can solve for A. A, I just do the same I just did. I get all of these and solve for it. Right? And A will be, in this problem, A will be force divided by mass total. So, what's that? Oh, wow, 100. Cool. It won't be that bad. So 60 times F divided by 100. So yeah, it's not that bad, right? 6 times, what is that? 6 over 10, which is, I can't do math. Sorry, who's this? Okay, cool. On to the next one. Here we go. Here's another example for you guys. So I have two weights, right? They're attached by a string and a pulley. Assume this pulley has no friction, and like I said, it's frictionless pulley, blah blah blah. What else? Frictionless table as well, right? Um, so what's gonna happen is since I have no friction, guess what? This thing should fall, right? I'm gonna go this way. So I'm gonna show you guys two ways to do this problem. One way is a little harder in my opinion, but in another way, kind of easier. But I'll show you how to do it. So the main concept of this is like I was saying. So you're gonna have two free body diagrams, right? I have two objects, so I'm gonna have two. I have this one and this one. So for the 3 kilograms, the force, the only thing I have is that tension, right there, going that way. And for the other one, I have tension and FG. Tension, and I'm gonna just say MG. I'm gonna shortcut. So then, what do I know about this system? If you said, "Oh, wow, Mr. Yambao, they both have A, right? They have the same A. The only difference is the A here is going this way, and guess what? What does the pulley do? It changes the direction. So for this part, A is going this way, and for this one, A is going that way. Those are my positives. That's gonna help me. So I'm gonna solve my problem. Like in this one, you wanna go with that one first. So the summation of all the forces in the x direction is T. I'm gonna make that positive equals MA, right? So on the other one, put it into pink. The only forces I have are in the Y, and I'm gonna make down the positive. Try to make the down positive because the same direction as my A, because that will help me when I solve. The forces, so this one is going down, so I'm gonna make it positive. So mg minus T equals to NO. So now, how many unknowns do I have? I don't know A, I don't know T. But guess what? I have two unknowns, two equations, right? I have this one and this one. So I'm gonna substitute in T here, and guess what happens? Mg minus what is the MA equals to MA. No, wait, what did I do? Um, I'm sorry. Let me go back. This mass right here is 3, right? 3M. So here I should do 3MA. So what I can do, I can bring that to the other side, makes it positive. Oh, guess what? Guess what cancels out? Mass, mass, and mass. Most of the time, mass will cancel out. A lot of the times, actually. So look, so if I bring this to the other side, it will G minus 3A is equals to A. And G is this for A. So A is this G divided by 4. Wow. So the answer will be A. So let me show you the second way I was saying. So that wasn't too bad, right? But we have to make two separate um, diagrams. So I have another way. What if I told you I can do this and make this my system? Which one? So I can summarize this whole thing by 4M, right? Just a mass. But what happens is, what's my external force for that? Okay. The only external force happening is being delivered by this, right? Which is small mg. So like I said earlier, let me draw it again. 3M, pulley, mass, like this. This is my system. Again, my force external equals to M A. The only external force I have is the mg, right? Mg. This mass right here will be the mass of the system, which is 4m times A. Guess what? M cancels out. And I get the same answer. B divided by 4. Wow. That one was quicker. You can do both, by the way, for these problems. But you just have to recognize that the force is only being applied to this mass, hence this, right? So this side is just that whatever is hanging, in my opinion. So then if you recognize that, you get the same answer as prior. Cool, cool. Okay, on to the next one. Okay. So let's do this example real quick. So this one, as you can see, is a pulley. It says, oh, it's from 1976. Nice. It says two guide rails for elevator shown above. It exerts a constant friction, okay, let me, 100 newtons for the elevator. Moving upward, okay. Its acceleration, 2 meters per second squared. The pulley has negligible friction in math. Assume G is 10. Okay, so let me draw two body for this, right? Okay. Okay. So whenever you guys see uh the two here, right? It's making contact with those. So what you're gonna do is you're gonna have two contact forces, which is friction. Then since it's going up, acceleration is up. This is my tension. Acceleration will be the opposite way. Sorry, friction. And then you have FG going down, right? So then when I sum my forces in letter B, the summation of forces in the Y, I'm gonna make up positive, make it the same direction as A. So C is positive, and everything else is negative. Minus FB, minus FF, I have two of them, plus NF. Combine the two F. And then it's looking for attention. Okay. Yeah, so I'm given everything except for, no, I have everything. So P is just FG, that's P, FF, that's MA, which is just 400 times 10 plus 2, what is friction? 100, 2 times 100 plus 400 times over A. A was 2 meters per second. When I do all the math, tension is 5,000. Cool. And then it says I need to calculate my counter rate. after I finish with the left side, I can do this too. So let me go to free body. For that one is tension is this way. And I'm missing N and G. This pound acceleration is this way, right? Yeah. Okay. The same thing. The sum of working from the Y. Method down is positive this time. Again, it doesn't matter. As long as you follow your own rules, you will get the right answer. Uh, so T was 5,400 times 10 minus 5,000. Wait, what am I doing? Oh, yeah, yeah. The other way, the other way. MG minus MA equals P minus P. I'm gonna be 8 P, which is, oh wait, what am I looking for? I'm looking for math. Kidding. So mass, the other way. Sorry, 5,000 divided by 10 minus 2, which is gonna give me 625. There we go. Okay.